Hello guys, welcome to another video. In this we'll be discussing about the Sustainable Livelihood Security Index. So before getting into the video, we need to understand some of the basic concepts like what does mean by index and what this SLSI can do. So index, which is an aggregate or composite indicator that has been calculated from several different weighted components. So sustainable development is that meets the need of present without affecting the need of the future generation. So sustainable livelihood is one which can cope and withstand the shock and vulnerability and maintain the physical and social well-being. So, Sustainable Livelihood Security Index, by calculating this index, it has the potential to function as a litmus to check whether or not certain necessary conditions essential for sustainable development are present in a given region or in an ecosystem. So, the sustainability can be categorized in three dimensions. One is ecology, second one is economy, and the third is social. So the economic efficiency or the economic dimension, which can indicate the use of natural resources with different technological conditions. The third, the social equity, is to make availability of economic benefits both for the present and for the future. So, with this, I would like to take you directly to the methodology how we are going to estimate the SLSI. So, as I initially indicated, there are three dimensions in SLSI. First dimension is ecological indicator. So, in ecological dimension, there are different indicators which we can use. So, I'll be taking some of the indicators which represent the ecological security of a region or a country or an estate or a village. So the first indicator which I have taken under ecological security is the forest cover, because forest cover plays a vital role in providing food security and livelihood to people living around it, and also it maintains the ecological balance. So here, one another important thing which we need to consider is that there are positive indicators and negative indicators, in the sense that the increase in particular indicator which increases the index, so or which increases the livelihood of the peoples, then we consider those indicators as a positive indicators. Similarly, say for example, the decline in forest cover leads to environmental changes through increase in carbon emission, which has a hidden cost for any country's economic growth. So here, the forest cover will be taken as a positive indicator. So similarly, I've taken cropping intensity, gross irrigated area, and net sown area. So also I've included some other indicators like the area under non-agriculture purpose and average operational land holding. So in India, majority of the small and marginal farmers, or around 86% of the farmers are small and marginal farmers. So it is very important indicator to be considered under this psychological dimension. And the second dimension is that economic efficiency. Here I've taken some of the major food crops because which increases the livelihood of the rural peoples and as well as the urban one. So here I've taken the cereal productivity, pulses productivity, milk production, and livestock population. As well as I've also included the rather including the gross domestic product. I've included the agriculture state domestic product. So it will says which states are having some positive positive indicators. So the third one is the social equity. First indicator which I have taken is sex ratio, literacy rate, population density, credit to agriculture, and population below poverty line, and ratio of small and marginal farmers to large farmers. So here you can see the variables which are considered as the positive indicators and the negative indicators. So based on the positive indicator and negative indicator, the method of calculating the index varies. So, and also I've given here the sources of data where I've taken the data. So I've taken the data time series data from the year 1988 to 2018, and to see what had happened in a overall time period. So here comes the methodology how we can estimate the index. So if you are going to estimate the index, so for example, if you want to consider the ecological indicator, economic indicator, and social indicators, in that we have certain indicators. So this first equation which is used to estimate if the indicator is in a positive indicator, which is nothing but xij, which is nothing but the value of a particular state or village or a or a particular country. Okay, so the next the which is compared with the mean value of the entire country or village or the state, and which is divided by the difference between the maximum value and the minimum value. So it is nothing but here we are going to compare the districts or compare the states which is having the highest value in the indicator, and similarly which is having the least value in the indicator. So this is how we are going to estimate. Whereas in case of negative indicator, we will be just using in the maximum value minus the actual value of the particular village or state or district divided by maximum value among the district or among the state, minus minimum value among the state or district. So with this, I'll directly take you to the STATA. So here I've collected the data. Here you can see E1, which is nothing but share of forest area, cropping intensity, irrigation share, and all the data I've taken, and similarly for all the states I've taken from 1980 to 2018. So with this, we need to find out the index for each. But first, we need to calculate the index for every indicator, and then we will be estimating the composite index. So I've given here the code which we can use it to estimate the values. So here we have time series data. So what I'm going to use is I'm going to use the bysort function because we need to estimate the index for every year. So I'll be using the code as bysort, which is nothing but for every year we are going to calculate it separately. So and another is I'm going to generate a variable. I'm naming it as ex1, which is nothing but the ecological indicator one, and I need to find out the maximum value. Say, for example, in this forest area, I have the data from 1980 to 2018, and for all states I have. So I need to find out the forest area where the forest area is very high, in which state the forest area is very high. Also, I need to find out the state which is having the least forest area. So that is the main first thing I need to do. So here I'm generating the code that is by sort by year, and generating in a variable ex1, which should give the maximum value of forest area. So let's see here, the variable has been generated, and I got the variable that is 0.725, which is the highest or the maximum value among the states during the year 1998. And a similar way for the 1989, I got another value. So this is how we need to generate the maximum and minimum values initially. So I'll do it for the rest of the things. So second, I'm going to do it for second I'm going to do it for yeah, 1 minute, for the cropping intensity. So in this way, we will be finding the maximum value and minimum value for all the indicators. Okay, so we got the maximum value and we now got the minimum value. So next is we need to find out the actual difference. So next is by sort year generate ecological indicator. Here we are going to use the actual value of the state minus the maximum value among the states divided by maximum value minus the minimum value. So we will be getting the index for forest area. So the forest area index here we can see for Andhra Pradesh it is around 0.25 and 0.17. So here we can see one, that is uh, it has the index ranges from 0 to 1, so which has a highest forest area compared with the other countries. So Union Territory, which has the highest forest area compared with other areas. So we got a value so of 1, and the state which has the least area under forest cover will have the value of 0. So in this way, we can find out the index for a particular indicator. So a similar way, we need to find out the index for all the states. So we need to find out the index for all the states so that it would be easy for you to calculate. So I've already written the code, and I'll just give in the description so that you people can also use the code for your for your understanding. So I'll just do the thing, and yeah. So we got all the indicators here for all the we got all the index for all the indicators, and now I'll show you the result. So here you can see the index which I've created. So here you can see during 1988, the ecological security index in Andhra Pradesh was 0.35, and the economic index was 0.26, and the overall index was 0.33. So that is so we need to concentrate on and when compared with the 2017, you can see the ecological indicator has declined by 5, that is point 0.5, 0.05. And whereas in case of economic indicator, it has increased gradually from 0.26 to 0.70, and similarly in the social equity, it has reduced by 0.04. So, but when compared with the overall index, so during 1918, the overall SLSI index was 0.33, and during 2017, we got a 0.45, which has increased absolutely. But when compared with the individual indicators, we can see there is a declining in forest area or some other indicators which we have used. So to identify which indicators had gradually declined, here I have given it. So from this table, you can actually see the forest cover has been around 0.25 during 98, and 0.30 during 2003, and 0.29 during 2017. So it has increased during between 2003, and it has reduced during 2017. So next you can see the cropping intensity also got declined, and the share of gross irrigated area also got declined, and so these are the indicators which we need to focus on Andhra Pradesh to increase the overall sustainable livelihood index. So uh, I hope you can understand how we are going to how we are estimating the index, and where we need to focus on improving the SLSI index. So here I have given a basic map where you can see where are the regions it has the high SLSI index, and medium and low. So I hope you have understood some basic idea on how to estimate the SLSI using STATA, and I'll just give this codes in the description so that you can also use it and make use of it in your upcoming research. Thank you.